Hey everybody, this is Larry, this is Miko Q3 of the weekly contest 360, minimum operations to form subsequence with target sum. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one, I struggled a lot with, obviously. I submitted with about literally 11 seconds left, which I was happy about. You want to watch the contest part where I was just so exhausted at the end. You could do that, it's fine. I think the hard part about this one is that it is greedy. And to be honest, I actually got the idea mostly correct. I mean, the thing is that I have three wrong answers, and this is a little bit of a contest discussion a little bit. So then fast forward or watch it on a higher speed if you want to just go to the explanation. But the reason why I have three wrong answers is because I had about like 3 minutes left or something like this when I submitted it the first time, because I knew that well, I mean, it doesn't matter how many wrong answers you get. If you don't get it right, then you have no penalty. So it's kind of a freebie. And I had the idea kind of with like 10 minutes left. But yeah, I just had to kind of do it, right? Yeah. But I had some edge cases that I didn't really have time to fresh out. So it was really worth every penalty that I took on this one. Because otherwise I was just not getting it. But the idea behind this problem is greedy, which is why it is very, very tricky, at least for me. I mean, you know, and what I mean, because I bet that, and you know, no offense. Well, I mean, 1,000 people got it, so I guess so. But even if I said the word greedy, you probably still have trouble solving this. At least I did anyway. Maybe I just speak for myself then. I mean, I kind of thought it was greedy, but I still had trouble solving this. The observations are kind of tricky to for me to enumerate. So hopefully I do an okay job. Let me know in the comments if I'm missing any things. I mean, and hopefully I think one of my pet peeves. It's not really. I don't really care enough to be a pet peeve, so maybe that's a strong word. But one of my things about things in the comments is make your questions actionable. And I don't mean to sound like, you know, I don't mean to sound like a mean person or whatever when I say like, you know, sometimes I get comments about, hey, can you explain this better? I'm like, I don't know. I mean, I guess so, but ask a question that will allow me to explain better so that I can explain better. Because if you're just like, hey, can you explain better? I'm like, look, at a certain point, I don't know what you don't know. And I don't know which part are you getting unclear on. And I don't know, like, if you want to, like, if I have a sorting function, do you want me to explain the sorting? I don't know, right? Like, anyway, my point there is just give me actionable feedback. And you know we'll go through it together, and also join Discord so that the communication is faster. That's all. Anyway, so getting that out of the way, the one of the observation, I mean, it's not an observation. They tell you in the first line is that all the numbers are powers of twos. But what does that mean, right? What that means is that they're only 31 or 32 distinct numbers, right? Whatever it is, right? 30 something distinct numbers, and that to break into a thing. So that's one. I mean, maybe you know that part is obvious, but it's something that yeah, by itself is obvious, but it still took me a while to figure out what that means, right? And then, but what that means is that the two operations really, you know, you have these things, and the operation is basically converting, you know, a number into halves, and then the other part is that you have a subsequence whose sums the target, and what that means is that, you know, if you put in a set or whatever, you can sum it. The subsequence just means that the components sum or something like this in my mind, right? And another way to think about it is that you can is think about another operation, which means that 16 plus 16, you could get 32, right? And that would come into handy maybe a little bit later. Yeah. So these are the two operations, except for that, obviously, given the parameters of this, you have this costs one operation, this costs zero operations, and you try to minimize the number of this. So how do you minimize this? Well, you minimize this by using the other operation as much as you can, right? the combining operation, and that's the part that I struggled with a lot. I had a notepad, physical notepad, and I kind of wrote a lot of different things and try to figure out how to greedy do these things together. But basically, now we look at the target, right? The target is some number, right? So, yeah, some number, and basically this number, obviously, as every number can, is a sum of powers of 2s, right? Or put another way, it is a binary number. If you look at it in the number of bits, right? So you can think about it as, just some binary number, right? And then the question is, okay, let's say you buy the premise that this is greedy, and this is the way that I thought about it during the contest. It's not quite, greedy problems requires, like, if you want to be rigorous about it, requires, well, a rigorous mathematical proof, which is really hard during the contest. But okay, given a number like this, what were you trying to do, right? Well, to be honest, the way that I thought about it is there's only, and it took me a while to kind of get to this point. So even though we're talking here and we're going really fast, maybe, and you can watch the live portion of this, it took me a while until I was just like, almost like I had nothing to lose, so I was doing it. But you can think about this as a binary number of bits, and you can really only go, if you're thinking about greedy, and at that point, like I said, I had nothing to lose, is either it's greedy or I had no solution. And I was thinking about a lot of other things too, like heaps and maybe like removing stuff and some stuff with invariants and for loops after sorting or something. Thought about a lot of these things, just couldn't fit it all together, right? And in this particular case, you can go from either left to right or right to left, to be honest, right? Like, there are really only two ways to think about it. And then, if this was the case, right? Because every other number is binary, so the reason, and let me go step one back for a second. The reason why these things are important, that these are binary numbers or powers of 2s, is that it means that like I said, there's only 32 or so distinct numbers. So that means that you could go from 13 to 16, you could go from 16 back to 32 if you have enough numbers, and so forth. But it also means that if you have two numbers, say you have 32, 64, 128, or whatever, if you are trying to construct a smaller number to the left, you, in a greedy kind of way, it makes no sense to take the 64 because you can always take the 32, kind of, because there's the reasoning being that if or maybe no, the reasoning being that it is not what's the word I'm trying to say? It is not path dependent. That's the word. So the thing is not path dependent, right? So for example, let's say you're trying to get 16 plus 32, right? Well, in this case, I don't know if this is a good example, but basically the idea is that, let's say, you need 16, so you break apart the 32. But then you may ask, oh, but we may need the 32 later, so why would you break it down? Well, the thing is that now you can rewrite this as, say, the idea is that here so the way to solve this is that you need to break down the 32 and the 64, and then the idea is that the order of operations don't matter, which is what I meant by path independent, right? Meaning that we have to do this anyway. So maybe another way to think about it is that we keep the 32, but then we break the 64 into 16. What does that look like? Well, so it goes from here to 32, 32, 32, 128, and then one of them goes to 16, 16, 32, 32, 128, right? Something like that. So versus if you just did it the other way, you have 32, 64, 128. You break the 32 down to 16, 16, and then 64, 128. But then now you need a 32. So then but you can see that in this way. it doesn't matter which number you choose if both numbers are needed. If only one number is needed, then you always want to take the smaller number for obvious reason, to minimize operation, right? So that's basically the idea. And like I said, here I've come from either left, and then now we could go back to here, where now in a meta cheating, whatever kind of way, we can only go from most significant bit to least significant bit, or the other way around. And then here, the idea is that why we want to do it this way, right? Is because looking at it this way from left to right, if we have this number, so we get this number, say, by combining smaller numbers, but then what if you need to break it down later, right? Let's say a really extreme example is this number, and then you have, I don't know, let's say you have 1 billion ones, right? Or something like this. I mean, this is a binary number, so it's not actually that much. What is that? What is that? 2 to the 12, so that's just 4,000, right? So let's say this is 4,097 or whatever it is. I don't know if this is quite right, right? So this is the target. Well, let's say you have 4,907 ones. If you to get this one, you would combine them all to make a 1, and then later you have another bigger number. Let's say, and then we break them apart again, right? So that doesn't make sense for me. For me, it makes more sense to kind of go in this direction, because here we can always combine and then split them up later, because when we split, like we said, to go from smaller number to bigger number, it doesn't matter, this is where the path independence, did I say path dependent or path independent? But anyway, the path independent thing comes into play, is that you need, if you need to shift things from left to right, you need to do it eventually anyway, and you get it for free. Oh no, that you don't get for free, but you get to combine for free. So then once you kind of pass a digit, you can composite all the numbers to use as possible. That's basically the idea behind this problem. It's kind of hard for me to explain because it's a hard problem in general, and you see a lot of debugging code still in here because I haven't had time to clean it up, and there's some code that is actually really not clean, to be honest, because like I said, I submit this with 11 seconds left, so really no time. But I'll go over my logic, and then we can talk about fixing this later, right? Actually, we could probably fix this quote unquote live together, but yeah, first, if the sum of nums is less than target, we return -1 because you just can't combine all the numbers to get the target, right? So it's not possible. Otherwise, it's always possible, right? Because if you have if the sum is total bigger than target, there's always an answer, because there's always an answer because you can just think about breaking them all into ones, and then if they're all ones, then you always have the answer. It's not the minimal move, but that's one answer, right? So after that, I don't think this is possible. I don't. Yeah, I mean, I don't think that's possible, but we'll see. But yeah, so here we do a frequency table, but we probably could have just used an array, because like I said, it's going to be an array with 32 elements or something like this. Yeah, and then here is from least significant digit first. So I did this, and the coding is very awkward, and because I was really rushing it. Again, 11 seconds to go. But basically, this is me trying to get the least significant bit and try to see if we could find a number to use for this, right? First, I kind of this part by itself. What does this mean? This is basically saying, and I kind of wrote this in a really awkward way. If we did it in a way, this would be cleaner. But it's not a big deal, only because there's only 32. There's only 32 numbers, right? Distinct numbers. So even if it's 32 square or whatever, it's fine. But it's still not clean though. So forgive me. But yeah, but basically this is saying that, okay, let's say our current number, and the current is our current bit that we're looking at. We actually shift this every time, so we probably could rewrite this in a cleaner way, and we'll do this afterwards. Let's rewrite this together. But yeah, so basically look for look for current, which is the power of 2, right? So if this is mod 2 is equal to 1, that means that this bit exists in the binary digits, so we have to find a way to add them together. So this part is the free summation part, right? Because every smaller number that we don't use, well, they're not going to be used anymore, because by definition of we already processed all the smaller numbers, so then we can combine them, and we can combine them for free, so why not do that? So that's basically the idea here. The code is a little bit awkward, but it's just basically for every number that's smaller than current, and if we have at least 2 of them, we combine them together to a bigger number, and then we update them to, and then we have to keep on doing it until we can't do it anymore, and that's because we did it in a funky way. Otherwise, or not even otherwise, after all the combining is done, we try to see if there's exist the smallest number that is bigger than current. I guess we could have done a binary search, but where f of x is greater than 0, right? So yeah, if this is found, we found and we break. Otherwise, if we can't find a number, we return -1. I don't think that's possible, but maybe I'm wrong on this one. I don't know. Otherwise, then here, we just break it apart, is the idea, right? If the found is not equal to current, we break it apart until it is current. So found, we subtract 1, we break it into 2, it costs 1 operations, and then we also divide it by 2. And then, yeah. And then at the end, we remove one of them, and that's it. It's greedy, and then we shift and add, we shift on both sides, and that's number of operations. Yeah, now this code is kind of yucky, so let's live solve this, or live refactor this. So yeah, so now knowing that, what I know, I can actually write this as 0 times, what is it? I say 32, right? Let's just say 35, why not? And then now for x in nums, for I in range of 35, let's call it max, right? And then if x is equal to 2 to the power of I always never know if I need paren, so I always put it. And then f of I, there's one example, right? So that's basically the thing. And then now we can keep this the same way, but we actually don't even need to do that. We can just do, for is it I? Fine, I in range of right. Oops, current is equal to 1 right? If target and current is greater than 0, then we do all these other things. So that already oh, well, now we don't need this. I think this should be good. Let me just check real quick. Oh yeah, of course. So maybe not, I lied. So we have to update here, but then now we can just do for I in range of mx, or for j, because otherwise we just miss it. I think that's fine, actually. I mean, shadowing is always a bad idea, so we shouldn't do it. But yeah, if 1 is less than current, and f of j is greater than 2, then f of j plus 1 increment by 1. C is equal to f of j, and then f of j is equal to f of j mod 2, I guess. It doesn't really matter. And here, then you don't need this update thing because you're going from left to right, and then it just kind of propagates upward. I think maybe I think this never happens anyway because we don't have enough things, but I just want to be careful. And then after that, this part is, yeah. So for j in, again, range of mx minus 1, maybe I can just write x is equal to and then the rest is basically the same. Found is, okay, so then now this is j, yeah, this is fine. No, that's just j, right? And then now, while 1 found is not equal to, yeah, and then this is minus 1 instead. So this would be the tighter code, assuming that it works. Oh, whoops. X is greater than current, and f of j is greater than 0. Just some. All right. Well, not quite what I was hoping. Why did I get 0 here? Oh, I forget to. Oh no, I didn't. Dong dong dong. But that's how I would ideally do it. Apparently, not exactly. Why did I get 0 here? So oh, I guess maybe this part is wrong. Did I change target or anything? This is very weird, actually. Let's see. Okay, so this is 4 and 8. So that's good. Oh, geez. Did I miss some part of this? For J, this looks okay. So this is 1, 2, 4, and trying to get a 4. Let's see if this does what it claims it does. This looks wrong for sure. Because it goes to a 3. Did I mess up? Oh, this started by 2. Whoops. Yeah, okay. Silly Larry. Alright, there we go. Just can't even copy and I don't know. Yeah. Let's give it a submit. And there you go. So this is basically the idea, greedy, and let me try to make it smaller just so I could squeeze it into one page. Maybe give it a bit. And you can write some parts of this easier, obviously, but yeah. Yeah. Cool. What's the complexity here, right? Well, let's go over it real quick now that we get it. Nums is O of n. This is O of log m, where m is the size of the numbers, which is 2 to 31, so about 31, 32. So you can say like O of alpha times n is this part, and this one is just O of alpha for the target, and there's another loop in here, so alpha square, nothing too bad. Alpha is, like I said, like 35 or something, or 32 really. So yeah, yeah, that's all I have for this one. Let me know what you think. Yeah, let me know what you think, and you could watch me really struggle on this problem until the end. I just want to say that, like I said, I got 3 wrong answers because I just had like weird, silly off by 1 hours, but I had no time to really test. As soon as it passed examples, I had to submit because, like I said, I had like 2 minutes left. And I needed every penalty to make it with 11 seconds to go. So, yeah. Anyway, that's all I have for this one. Let me know what you think, and you can watch me solve it live for some loosely interpretation of that word. Now, literally the same problem, right? Very confused. All right. Just let me. Oh, if it's auto even. Subsequence cruise sum is target. This just needs the components, right? So it doesn't even have to be the n. Right. Number's gonna be pretty big, 1,000. Okay. It doesn't say that. Oh wait, it does. Okay, I don't know how to read. But is that the only case? Otherwise, you can always do it because you can always just have a bunch of ones. So then now you're trying to find a min then, right? Because if the total is, because it's power of 2, so you can just have all ones anyway. So we're trying to find so 12 is 6, 3, 2, so 4 times 3. So 8 and 4. Do you always use all the numbers from previous? Do we ever need both components? I guess so. If you have, well, for example, if your target is 12 and you only have one number, then you need both components, so you can't just throw them away. Is that true? And it's 1,000. What does that mean? I do some sort of yes, no. Target is pretty big. $32, 16.8, and 8.4. So that's, but that's not close, right? Oh, it's a subsequence. A sequence of operations, not just shortest subsequence. So that means that we should use the existing stuff as much as possible in theory. If we sort it, what does that mean? It is not. Let's say the number is 32 and the target is 31. Then what? And you need to kind of decompose everything up to -1. We sort way to the perfect zone. The binary. I don't know how to do this one, to be honest. Is it TP? What would you even TP on? Is it a bitwise thing? All powers of 2s, what does that mean for me? Does that mean greedy works? I do not know this one at all. I'm gonna skip ahead. Only one person got it, so maybe not even that good either. Yeah, that. Well, it is pretty big. Can I do a use, not use? No. I don't even think I really understand this farm, to be honest. Do we always want to use numbers if we can get it for free? People are starting to get it. I don't even have an idea. just don't like pseudo polynomials. N is equal to 1,000. Is there some n square thing that I don't know about? Is it a prefix suffix thing? Should I actually skip ahead? This is a medium too. They're both mediums, but I don't even know how to do it. Maybe they're both hearts. Alright, let's skip ahead. Let's actually read the dated way. I mean, I feel validated for sure. I probably should have done it the other way, but I think, what am I doing now? I mean, I did it in a really. Alright, you have 18 minutes, finish it. Finish it. How do you do this? It's greedy, for sure, right? Because it's only divided by 2, so you always want to choose the smallest number that's bigger than target. That's, yeah. Yeah, because you only divide by 2. Okay, I see. So while, do you ever not want to order numbers? Yeah, because if you have like target is equal to 4 and you have 1 and 4, or even 1 and 8, then you don't want the 1. The 1 does nothing. And a lot of people got this though. Alright, you still have to. So you can't do greedy like that. Is it enough to know that? No. I don't get it, to be honest. And that composition matters, because if you want to have an odd number, is it just how do you even do the sum? The sum part is the part that gets me. Like this part, 1 plus 1, right? I guess I'm not wrong to skip this, but I have no idea. Sorry. how would I even greedy if I want to do greedy? That's what I'm trying to figure out. And this is there a DP? If we sort, can you kick out numbers? What is the invariant? I mean, as you get bigger numbers, do you ever want to kick out the phone? Maybe just collections.counter. No, for okay, if this is unit 1, then we get this smallest number that's bigger than it. These are all powers of 2, so so if x is greater than or if current is greater than equal to x, then we break. We want found is equal to x, and then now we greedily okay. F of I don't think that's possible, but okay. If the found is not right. Okay, right. So then now found is equal to current. So then f of found 1, and then that's it. Or operations, I suppose. Oh, that doesn't make sense. Jeez. Is this part? Okay, fine. Current is, oh, this is greater than X, not found. Wait, no. No. It's current, but what are you doing? All right, 8 minutes. Why is that overlooping? Oh, and f of found is maybe still do why? 6 minutes. Okay, looking for 1. Okay, and found 1. That's good. Looking for 4. Found. Why? If current is less than, oh geez, Larry. Can you be dumber? 1, 2, -1. Okay. I don't know if this is right, but I'm gonna have to YOLO it. Why did I do 1? Oh, I left the break in here for debugging. Oh, but now it's 1, 3. So that's not right. Greedy doesn't work, maybe? Let's see. I mean, maybe if it's just wrong, it's wrong anyway, but... Five minutes. Can I do in 5 minutes? Target is 12. Breaking 16 to 8. Oh, because I'm doing it the lowest bit first. Oh, I have to use the sum. I didn't do the sum, did I? So this was wrong anyway. I forgot to use the sum. Otherwise, okay, so we have to combine them then. Okay. If x is less than current and f of x is greater than 2, you go to 2, and f of x divided by, oh, okay, x we is equal to x mod 2, and then f of x times 2 is equal to c divided by, yes, c divided by 2. Hopefully that escalates. Still 3. Let's see. So 1, 2, 8. Okay, fine. Let's see. Target 12. We break the 32. Okay, down, but that's. I don't have enough time to debug everything. I have 3 minutes. Okay, so this counter is wrong, is it? Oh no, there's 2. So then the 2 goes to 1. Right, so it combines. It tries to find 4. Oh, target is wrong, isn't it? Target is remainder. Oh man, I'm not gonna finish because of this. Okay, so you merge 4. How? You start with this. How do you get this? Oh, add. Wow. Okay, so this is right. So let's remove all the. Oh, I don't know if it's right, but it is passing the examples. We have plenty of time. 1, 2, 4. All right, that's. Ah, well. Wait, why? Oh, this is Leetcode 2 then. Whoops. It's still wrong though, but I don't have time to debug this. I mean, I feel like I'm close, but oh, 2. Okay, so where's my extra print statement? Is right here. I'm watching a little bit because I just don't have time. So I'm submitting it for no reasons. But 5. This is the thing I'm worried about. So oh, I didn't delete this. Oh no, I did. I'm so close, but I just kind of not able to do it, I guess. So this I do 2 because 1 for 4. Why? Merge 4. I merge all them once. Oh no, this shouldn't be. This is actually wrong. I just didn't. That was a rough fix. Let's give it some. I mean, the wrong answers were because I just had no time, right? But yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and this contest, this explanation. Ask me actual questions. Yeah, stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.